Okay, today we will discuss the first application of dimensional analysis, that is to check the dimensional correctness of a physical relation or a physical equation. For this, we have to remember certain facts which will help us to solve the numericals in a better way. So, first thing that you have to remember that only similar quantities can be added or subtracted. Quantities whose nature is different cannot be added or subtracted. However, quantities of different nature can be multiplied or divided. This is also known as principle of homogeneity of dimension. So let me write it here. So this fact is also known as principle of homogeneity of dimension. Let us take an example. So we know that length and time are quantities of different nature. So when we try to add length with time, then it is not allowed. However, if we try to divide length with time, then this is allowed, and you know that such kind of operation is done while defining speed, which is the ratio of distance up to the time, and velocity. So the definitions of speed and velocity clearly tell us that it is possible to divide length with time. However, it is not possible to add length with time. So principle of homogeneity of dimensions only justifies this fact that the quantities of same nature can be added or subtracted. Now we have understood this fact. Let us now take an example. So we have to check the dimensional correctness of this equation. mgh plus half mv square is equal to half kx square. Here actually k is the spring constant. K is spring constant, and x is position, h is height, v is velocity. Let us try to solve this problem. We will be checking the dimensions of these three terms. There are total three terms in this equation. The first term is mgh, second term is half mv square, and third term is half kx square. So g is nothing but it is acceleration due to gravity. So for us, its dimension will be therefore lt minus 2. So as I have told earlier, total number of terms are 3. Number of terms on the left hand side of the equation are 2, and number of terms on the right hand side of the equation are 1. Let us now find the dimensions of first term on the left hand side, that is mgh. So the dimensions of mgh will be obtained by putting the dimensions of m, then g, then h. So m has dimensions capital M, g because it is acceleration due to gravity, so its dimension will be lt minus 2, and h, it is height, it comes in the category of length, so its dimension will be L. So the dimensions of the first term in the equation will be ml2 t minus 2. Let us now see what will be the dimensions of the second. So the second term is half mv square, out of which this half is a dimensionless quantity, it is just a number. So the dimensions of half will be m0 l0 t0. Dimensions of m will be mass, and v is velocity, so its dimensions are lt minus 1. Since it is velocity square, so there will be square of this. If we solve it, you will get the dimensions to be ml2 t minus 2. So the dimensions of first term are ml2 t minus 2, and that of second term are also ml2 t minus 2. Let us now find the dimensions of third term, that is half kx square. Again, half is just a number, so its dimensions will be m0 l0 t0. K is spring constant, and spring constant, or it is also known as, actually spring constant is also known as force constant. So its definition, it is force per unit length. So the dimensions of force are actually mlt minus 2. If you divide it by length, then the dimensions of spring constant become mt minus 2. So these are substituted here. X is again the actually extension in the spring length, so it comes in the category of length, so dimensions of x will be L. So when we solve these, you will again get ml2 t minus 2. So we can come to the conclusion that dimensions of all three terms in the given equation are the same, hence the given equation is dimensionally correct. Thank you.